Hello everyone, welcome back to another video. Today we're going to take a look at Maths Paper 2. It's a reasoning paper from the 2023 SATs. Let's dive straight in. So looking at question 1 here, we have circle the clock that shows 5 minutes past 11. This question is also testing your Roman numerals. So let's take a look here, 5 past 11. Well, in this one here, the minute hand's pointing to 1, which in this case is 5 past. So this is good. This is 5 minutes past. But look at the hour hand. It's just past the 2. This is 5 past 2. Now, the tricky thing here is obviously we need to convert the 1s and 2s in Roman numerals, but we also need to know that when it's minutes, we're counting up in 5s. When it's hours, we're just counting normally in 1s. So this here is 5 past 2. That doesn't work, obviously, so we can get rid of that as an answer. Over here, again, the minute hand is at 5 past. That's good. It's promising. It's very promising. And very quickly, before I carry on, I'm going to show you something. Look at the other two. The minute hand here is 5:02, so it can't be this one. And the minute hand here is at 10 past, so it can't be that one. So we already know it's going to be this clock. 5 past, look at the hour hand. XI is 11, because X is 10, I is 1. Therefore, this is the clock we have to circle for question 1. Question 2, write these temperatures in order starting with the lowest. Now, they've been very kind here and literally said lowest instead of just ascending or descending order. Now, this is about negative numbers. And if we think about negative numbers, we have a 0 here. And then as we increase, numbers obviously just go up normally. 0, 1, 2, 3, pretty standard. Now, the trick here is that as we go past into negative numbers, the digits seem to go up. So -2, -3. And the problem here is that something like -3, you might look at the 3 and think, oh, 3 is bigger than 1. But no, it's not, because it's a negative number. The further we go along, the colder we're getting. So for example here, go all the way down to -10, this would be by far the most cold. And that is our first one here. The lowest temperature is -10 degrees. Then we can cross that one out. And now we only have one more negative number. So it must be -4 goes in here. And then it's just a simple case of normal numbers, really easy at this point. 1, 3, and 6. Trick there, got to take account of the negative numbers. Question 3, we have coordinates with a triangle that's been plotted here. Let's look at the question. ABC is a triangle, we can see that. What are the coordinates of point C? A simple reading of coordinates. Point C is here, and to read coordinates, we start at the origin, 0, 0. And we read across the x-axis first, we get to 6, so we know the first number here is 6, and then we count how many squares up, which here is 2. So the coordinate of C is 6 across, 2 up, it's 6, 2. Question 4, some children choose their favourite zoo animal. The pictogram shows the results. The key is always super important in the pictogram. Luckily for us, it's quite a simple number of just 2. Before I even read the question, here's what I'm going to do. I'm going to count up and convert these symbols into numbers. So penguin is 3 lots of 2, so that's 6. Elephant is 2, 4, and then half of 2, which is 1. So this gives us 5. Tiger is 6 circles, multiplied by 2 is 12. And giraffe here is 1 circle, which is 2 and a half. That gives us 3. So these are the favourite zoo animal of children. Let's now look at the question. How many more children choose tiger than elephant? So tiger was 12. Elephant was 5. To find the difference there, we just subtract 5 from 12 and we get 7. Quite simple there, but it's only simple because we spent the time actually decoding the pictogram in the first place. Really good technique. Cars and motorbikes are parked in a street. Car, 4 wheels. Motorbike, 2 wheels. Stefan counts 3 motorbikes and 5 cars. He counts 28 wheels altogether. Explain why Stefan cannot be correct. Why can Stefan not be correct? Well, let's take a look here. 3 motorbikes, 3 times 2 is 6. So there we've got 6 there, and he counts 28 wheels together. So we've got, for the cars, 5 times 4. That's 20, and we get 26. Now, the question wants you to dive a bit deeper here, okay? It wants you to think, okay, well, one way you could explain this in words even more succinctly than just doing some maths is to notice that 28 is a multiple of 4. Now, here's the problem. 5 times 4 is fine. That's no problem. But then we have 3 times 2. 6 is not a multiple of 4. So it cannot ever add up to 28. So in this example here, you could use that as an explanation. There are 3 times 2 is not a multiple of 4 because it's an odd number we're multiplying 2 by. Therefore, it can never give the answer of a multiple of 4, which is 28. It does not work. So we've got some maths to prove it, and we have also some explanations using multiples as a link to say no, not possible. Question 6. Kirsty buys 1 litre of apple juice for £1.39 and she pays with a £5 note. How much change does Kirsty get? This is a classic question. Change is very, very, very often comes up. You could do 5 and then put in your 2 placeholders for £5, and then you could subtract £1.39, making sure the decimal goes in the right place. There'd be lots of exchanging. You get the right answer. Or what you might want to do if you're more confident, you can count up to calculate change. So starting at £1.39, you're going to work out the difference up to £5. The way to do that is to know your number bonds to 100. If I already have 39, then I know I need to add on 61 pence to get to the next pound, which is £2. Then £2 to £5, sorry, I'm getting ahead of myself, is £3. So £3, 61 pence, put it together, and that's how much change she would have received, £3.61. Question 7, here's a number sequence. Write the next 2 numbers in the sequence. This kind of amalgamates 2 objectives. The first one is counting up and down in 25s. So we notice here 75, 50, 25. You might notice that pattern of 25s. So take away 25 from 25, we get 0. But then if we want to take away 25 again, taking away any number from 0 is super simple because we go into negative numbers and we have minus 25 or negative 25, as people like to correct me sometimes. Both are acceptable, minus negative 25. Question 8. In 2012, there were 24,372 schools in the United Kingdom. Round the number of schools to the nearest 100. Now, I have a technique on this, guys. We have a video on our channel about rounding. Go and look at it. It's a super, super simple way to round. I'm going to show you it right now. We're rounding to the nearest 100. So I'm going to underline my number from the start up until I get to the hundreds column and then put a wall up. So I know now that my answer is either going to be 24300 or 24400. To figure out if we round up or down, circle the number past the wall. It's a 7, so that's a high number we're going to round up. Therefore, the answer is 244 hundredths. So making sure we put that 00 at the end. Or, to read it in a more traditional way, 24,400 schools. Question 9. Here are some diagrams showing parts of a circle. These are just facts we need to know, guys. When we get to do the SATs paper, we need to know what the diameter is, the radius, the circumference. There's nothing to work out here. We just have to match each name to the diagram showing that thing. So, for example, circumference is the total distance around the circle. Radius is from the center of the circle to one of the edges, well, the edge, and diameter is a straight line right across the middle through the center of the circle. So that's how we'd match up those. Question 10. Ken thinks of a number. He divides it by 3, and the answer is 72. This is a simple inverse machine. We start with a number, we divide it by 3, and then we end up with 72. So we have to go backwards now. We do 72, we do the inverse of divide by 3, which is multiply by 3, and we get 216 as the answer. Question 11. Write the number that is 1,000 more than 19,039. The clue is in the actual way we say the number, guys. 19,000. What's 1 more than 19? Because that's how many thousands we have. It's 20. And then I've just got to make sure that we write the rest of the number correctly. 20,039. Next one, write the number that is 100 less than 19,039. Classic here, guys. The reason they're asking these 2 questions is this one goes past 0, going up. And this one, we start with nothing and we have to take away 100. It looks like we can't do it. Again, there's a few ways to look at this. You could just do minus 100 in column method and do it that way. It will take a bit of time. Or you can notice that this is the same as 190 hundreds. What's 1 less than 190? 189 hundredths. Then just make sure you put the 39 on the end. 18,939. Simple. Question 12. Draw all the lines of symmetry on this shape. Okay, so straight away I can see a vertical line of symmetry. A line of symmetry is a line where, if you were to fold across that line, the corners and the edges and the shape would fit perfectly on top of each other. There is one more line of symmetry here, and we have to use these dots as a reference to make sure we get it absolutely right. There is a horizontal and a vertical line of symmetry, where if I was to fold them, they would fit perfectly. There is not a diagonal line of symmetry here because these 2 triangles would therefore not line up perfectly. And in a rectangle in general, there's no diagonal line of symmetry, only in a square. Question 13. 1/5 of a number is 22. What is the number? This is another case of inverse operation. So we've done the answer. We say 1/5 of something equals 22. So we know that if we draw a bar model out with fifths, 1, 2, 3, 4, the worst bar model ever, we know one of those is 22. So to work out the original number, we have to do 5 lots. That's not a 7, by the way. We have to do 5 lots of 22. So instead of dividing by 5, we now multiply our answer by 5, and we end up with 110. That's our answer. Question 14. Measure angle A. Now in this question, I don't have a protractor on my screen, okay? But I'm going to teach you how to use a protractor properly. When you see a protractor, you have to line it up perfectly. So this line here would be off. This line here would be off. These would not count perfectly, okay? It's really important that when you use a protractor, I'll draw it up here, you will see that there is a line like this that forms two 90-degree angles, and it kind of curves around. So the whole protractor might look like that, and it will have lines going off it like this. A really bad protractor drawing, but you get my idea. It would look a bit like this, and this is the important thing. This line must line up perfectly, so you'd rotate your protractor around, and then you'd make sure that that is perfectly lined up, and then you'd go to around your protractor like this, go around, and you'd have to stop measuring right there, okay? So again, I can't measure this for you in this question, but what I can say is in the comments down below, if you go and find it, I'll tell you what the answer was for it in this paper. Question 15. Here are 4 fractions, 1/3, 1/6, 1/4, and 1/2. Write the fractions in the correct place on the number line. Now this is almost like an equivalent fraction question. 0 to 1. First, you think about how many parts there are on this number line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is out of 12. So here's what I need to do. I need to look at these fractions here and think, what would they look like if I converted the denominator into 12s? Well, 1/2, 2 times 6 is 12, do the same to the top, we have 6 12s. So the 1/2 card goes 6 along. 1, 2, 3, 4, 5, 6. You could have equally just worked out that it was halfway. Next one, let's do 1/4. How do I change 1/4 into 12? So I multiply it by 3. Do the same to the top, and I get 3 12s. So 3 along, I'm going to write 1/4. 1, 2, 3. 1/4 is going to go right here. Next up, 1/6. How do I change 6 into 12s? I multiply it by 2. Do the same to the top. 2 12s. So 2 along, I'm going to put 1/6. You get the idea. 1, 2. This is 1/6. And finally, 1/3. How do I change that into 12s? I multiply it by 4. Do the same to the top. And that means in this last one here, I'm going to write 1/3. So that's how to answer that question accurately every time. Question 6. One day, last year, the rate of rainfall from 6:30 a.m. until 9 a.m. was 2 millimeters per hour. What was the total rainfall from 6:30 to 9 a.m.? So the first thing we need to do here is figure out what is the time difference between 6:30 and 9 a.m. so we can find the total amount of time that we're measuring the rainfall for. 6:30 to 9, well, 30 minutes here is going to get us to 7. So that's half an hour, which is going to be really important because 30 minutes is half an hour. 7 to 9 is 2 hours. So we have 2.5 hours or 2.5 hours or 2 minutes, 2 hours 30. So the rate was 2 millimeters per hour. So we have 1 hour, 2 millimeters. 2 hours is another 2 millimeters. So that accounts for the 2 hours. There was 4 millimeters there. How much rainfall would there be in half an hour? Well, 2 mils for a whole hour. So half of that is 1. So we have 2 plus 2 plus 1. That is 5 millimeters of rain in that time. Question 17. The manager of a flower shop orders 4 boxes of red roses. There are 50 roses in each box, and the manager makes bunches with 6 roses in each bunch. What is the greatest number of bunches that can be made? Show your method. That means it's going to be multiple steps. If you make one arithmetic error, you can still get a mark if you show every single step. You can't just do one step to get 1 mark. We did a video on mastering these 2-mark questions. Have a look at that one, guys. But let's take a look here now. Firstly, 4 boxes with 50 in each box. So the first step here is to do 50 multiplied by 4. I would be doing times table facts for this. 5 times 4 is 20, but it's 50, so make it 10 times bigger. There are 200 roses. Then we need to take these 200 roses, and we're going to put them into groups of 6, because that's how many roses are in each bunch. Then if we do that, then we're going to do a short division. Let's see how many whole bunches we can make. 6 is into 2, do not go. 2 carrying over. 6 is into 20, go 3 times. with 2 left over because 6 3s are 18. And again, 6 is into 20. You guessed it, it's still 3 times. And there's going to be 2 roses left over. So this number here tells us how many bunches we can make. And this number here tells us how many roses will be left over at the end. So the greatest number of bunches he can make is 33. That would use 198 roses. We don't have enough left over. We only have 2 for the next bunch. So he can make, or she can make, 33 roses. Question 18. A cinema sells tickets of 3 different prices. 1/20th of the tickets are price A. 3/5 of the tickets are price B. The rest of the tickets are price C. Let's go down a bit to fit this in. What fraction of the tickets are price C? This is just a case here of working with denominators with different fractions with different denominators. Let's make them all 20th. So we got 1/20th is A. I'm going to convert B into 20ths. Now, to go from 5 to 20 here, we have to multiply by 4. Do the same to the top to make it equivalent. We get 12. So here's what we've got now. We've got 12 20ths plus 1 20th. That gets us 13 20ths. And we know that the rest of the tickets are C. So we've got 1 take away 13 20ths to see what's left over. And what you need to realize here is that 1 can be written as 20 20ths. All of the 20ths would make one whole. 20 take away 13. The answer there is 7 20ths. Question 19. Write the missing number to make this division correct. 15,000 divided by what equals 75? This is a really interesting and tricky question, in my opinion. So firstly, let's think about powers of 10. How can I get this down to a more manageable number that's much closer to 75? So if I do 1500 and I divide that by 10, I'll get 1500. Still ages away. But I've also noticed I could divide it by 100. 15,000 divided by 100. Therefore, we're going to shift our digits down and end up with 150. Aha! So now I've got 150. What can I divide that by to get the answer of 75? And you may have noticed there is a clear link between 150 and 75. The answer to that link is that it's doubled, so we have to halve it. So what we've done here is divide by 100 and then divide by 2. Now, in order to write this as one division, we have to find the product between 100 and 2. So this is the same as dividing by 200. Now, there's another way you could have done this. You could have counted up in 75s. For example, you could have done 75. You could have done 2 lots of that is 150. Okay, cool. I know 2 lots of 150. How do I get from 150 to 15,000? We just said we multiply it by 200 by 100. So 200 lots would be 150, but 100 times bigger, which would get us to the answer as well. So a few ways to do that there, mainly relying on things like chunking and counting up quickly. Question 20, write the 2 missing digits to make this long multiplication correct. Whew. Okay, so here, 3 times 5, we know that's going to be 15. So I'm going to put a 1 in here. 3 times 3 is 9, which would make 10. So I'm going to put that exchange over. In these questions, you often have to write down the exchanging. That's what's missing. 3 times 2 is 6, plus the 1 is 7. So now we've just got the simple question. 3 times something would give us 9. That's obviously 3. Now let's go to the next line. 0 is just a placeholder. Okay. Now this is where it gets tricky. We need to think, okay, something times 5 ends in 5. Well, it's not necessarily 1. It's not necessarily 2. It's not necessarily 3. It's going to be a really tricky way to do this because we could have any number that ends in 5, right? So 5 times 1, 5 times 3, 5 times 5. So let's keep going for a minute. And then the next one is something times 3 ends in a 7. Now, I see a problem straight away with this one because, okay, what can I multiply by 3 to end with a 7? That doesn't work, so we have to use exchanging. And we can go on the meta level here and think, okay, the question is basically asking us 3,235 multiplied by something is this number here, 16,175. Now, straight away, I'm thinking, okay, what's a sensible answer to put in here? And we can use trial and improvement if we really want to. Now, you could notice straight away that 3,000 up to about 16,000, that's about 4, 5, 6 times. So you might try in here 3, because you know it has to end in a 5. 3 times 5 is 15. 3 times 3 is 9, plus 1 is 7. That doesn't work. So you know 3 doesn't work. Okay, let's try 5 lots then. 5 times 5 is 25. 5 times 3 is 15, plus 2. That would give me 17. This is starting to work. So this looks really promising now. 5 times 2 is 10, plus the 1 is 11. 5 times 3 is 15, plus the 1 is 16. So 5 works perfectly. Now, there are a few ways to do this. You could have noticed that 3,200 gets close to about 16,000 when multiplied by 4 or 5. Trial and improvement using this space down the bottom is a really good method. But the one thing you have to remember is the exchanging. So 5 5s here would bring a 2 over, and that's what's going to allow you to solve this question. Excuse me, question 21. The height of the tallest person in history is 8 feet 11 inches. Oh my goodness, they'd be very good at basketball. Conversion table. 1 foot is 30 centimeters. 1 inch is 2.5 centimeters. Use this table to calculate the height of the tallest person in centimeters. Show your method. Do it. So 8 feet. 1 foot is 30. So for 8 feet, we need to do 8 multiplied by 30. 8 times 3 is 24. Make it 10 times bigger is 240 centimeters. That's already huge. We're still not finished. Then we have over here 11 inches multiplied by 2.5. So to multiply by 2.5, you can multiply by 2. We get 22. And then multiply by 0.5, which is the same as halving. Half of 11 is 5.5. So we add these up and we get 27.5. But we've also got to now combine this amount and this amount. So 240 plus 27.5. And we can put a placeholder in here if we want to. And we get 0.5 at the end, 7 in the ones, 6 in the tens, 2 in the hundreds. That is one tall guy, 267.5 centimeters. Here is a regular hexagon. The area of the large shaded triangle is double the area of the small shaded triangle. Hopefully you can see that here, because really it's just this half's been taken off, isn't it? These are the same and that half's just been taken off. Let's see what the question asks us to do. What fraction of the whole hexagon is the shaded area? My goodness, I love this question. This is what it wants you to do. It wants you to make the hexagon split into these small parts. So cut across here, and then cut down here. You can now see we're in this many parts, and all we have to do is halve each of these triangles to get equal parts that are the same size, and then we know 3 of these are shaded. So 1, 2, 3 are shaded. So we put 3 as our numerator. How many of these small parts are there in total? Well, we know it's a 6-sided shape, and each side has 2 spaces, so it's 12 in total. You could put also 1/4 if you wanted to. So you can count that to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3 out of 12, or 1/4 of that shape was shaded. Question 23. A small box contains 650 grams of cereal. A large box contains 20% more. One portion is 40 grams. Lots of information. So let's go to the question now and find out what we've got to do. How many full portions are there in a large box? Show your method. So the first job is to work out how many grams are in a large box. So 20% more. So we need to find out 20% of 650. So that's a really easy thing to do, because we can just find out 10%. So 10% of that number is 65. We just divide by 10. So 20% is 2 lots of that, which is going to give us 130. So there are 130 grams extra in a large box. So in a large box here, we're going to do 130 plus the 650 that we started with. A large box has, 780 grams. So 780 grams in a large box. And then what we can do is 780 grams divided by 40 grams. Now a little trick here. This is the same, because the zeros can cancel out, as doing 78 divided by 4. We can do that. That is absolutely fine. So let's do 78 divided by 4, because remember the question is how many full portions. So 78 divided by 4, we can use the bus stop method to do this. And we can divide by 4, 1, 4 and 7 with 3 left over. And we get 9 4s are 36. So there's a bit left over, remainder of 2. So here is 19 full portions. If you wanted to check that and make sure I was correct, you can do 19 multiplied by 40. See what you get. You're going to be really close to 780. Okay. Next one, 24. 1,200 pupils will ask this question. How important is it to have a break when using a screen? By the way, it's very important. You're watching a screen right now. I'll make sure you have a break after this. This chart shows the results. Very important, not important, quite important. How many pupils answered very important? This wants you to work out this percentage. Now, so the first step here is to think, okay, 12 plus 41. That's going to give us 53%. So 53% was the rest. So this part, very important, is 47%. I've written percent twice. Doesn't matter. It doesn't matter at all. So 47%. So what it wants you to work out is 47% of 1,200. So 47% of 1,200. This is just like a arithmetic question at this point. 47% of 1,200. Let's work out 50%. I like to do shortcuts. 50% equals 600. And then we want to work out 3%. So if 1% is 12, because we divide by 100. So 1% is 12, 3% is 36. Now if I take 50%, if I take away 3%, I'm going to end up at 47%. So 600, take away 36. The answer is 564 pupils. A lot of work there for 1 mark, but I guess it did turn into basically an arithmetic question here. Okay, next one, question 25. There are 25 sheets of paper in a small pack. There are 500 sheets in a large pack. How many small packs make 1 large pack? Let's think of it this way. 25 is 1. So what would 10 lots be? Always chunk up to 10 would be 250. And I notice a little pattern here between 250 and 500. It's half. So if I double that, if I don't have 10 packs, if I have 20 packs, that's going to give me 500 sheets. So there are 20 small packs in a large pack. The mass of the paper in the large pack is 2.4 kilograms. What is the mass of 1 sheet of the paper in grams? Now, first thing to do when it's 2.4 kilograms, we need to go and change this to 2,400 grams. That's the first step. Now, there are 500 large sheets. So what's the mass of 1 sheet in grams? We need to do 2,400 divided by 500. Now, remember my trick from earlier. We can cancel out when we're dividing like this. So 2,400 divided by 500 is the same as 24 divided by 5. And I'll show you why that works. 2 divided by 10, that's obviously 2. That's 20 divided by 10 is 2. 2 divided by 1, by cancelling the zeros, is still 2. It doesn't matter. It still keeps the same answer. So what we have to do here is 24 divided by 5. We're going to go into decimal places. Obviously nothing in there. 5 into 24 go 4 times with 4 left over. So put in your placeholder there and add the 4 that we've exchanged. 5s into 40 go 8 times, and that's perfectly done. So 4.8 grams per sheet of paper. Next up, question 26. This formula is used to estimate the mass in kilograms of young children. Mass equals 2 times their age in years plus 5. This is order of operations. Stefan's sister is 4 years of age. Use the formula. So we swap in 4 here. Now we have to do whatever's in the brackets first, even though addition comes after multiplication. Because it's in the bracket now, we have to do that first. 4 plus 5 is 9. And then I have to multiply that by 2. And that gives us 18 kilograms. Now we're going to have to work backwards. The mass of Megan's brother is 16 kilograms. So we now have to work out her age. 16 equals 2 times something, which is her age, plus 5. Now we know that 2 times this answer here has to be 8. Because 2 times 8 is 16. So how can I make this answer 8? We put in a 3 here. And the answer is 3 years old. That is the end of this paper. Guys, I hope you found that useful and you can see how to answer all of those questions. Let us know down in the comments below how you think you got on, how many questions you think you'd get in that test if you were to take it. And let us know if you want us to do paper 3, which is another reasoning paper. Give this video a like, share it with someone who you think it'll be useful to. Subscribe to our channel, hit the bell. We've got loads of videos on the way. Thank you so much for watching. I've said enough now. Bye.